right, hello grade 9s and 10s, and even in our school we even start the straight line in grade 8 as well, but most of this would be applicable to grade 10 only, but maybe if your teachers were a little bit of ahead of time, you would start this in grade 9 as well. So we do this very thoroughly in grade 9, so that when we get to grade 10s, we can only when we get to grade 10, we can only focus on the parabola and the hyperbola and the exponential graph with the functions. So I'm going to run through it. Maybe you're in grade 10 and you just want to revise through your straight line. Then this is a worksheet for you. This covers all the types of questions that you can get with the straight line graph. All right, so let's have a look. So it says a line has an equation as y is equal to 3x minus 4. Sorry, just had to get my pen out there. All right, a line has an equation y is equal to 3x minus 4. Write down the gradient of the line. So if you think of a straight line, it always has the cookie cutter mold. I don't know, I always use that, and I think everybody just knows what I'm talking about. So the gradient is here in front of the x, and the y-intercept is at the back of your equation. I always say the backside is the y-intercept. The backside is the y-intercept. But this is your gradient. So this is going to show whether the graph is going up or whether the graph is going down, always from left to right. And this is if you've got a Cartesian plane like this. This is where it will cut through on the y-axis. So if it is there at -3, it might look something like that. Or if it is at +2, then it might look something like that. Okay, so this is where it cuts through on the y-axis. All right, so write down the gradient of the line. The gradient is the 3, and we always indicate the gradient with an m. Okay, with a m. Okay, write down the y-intercept of the line is -4. So you can either write it as y is -4, or you can write it as a coordinate as to where it will cut through on the Cartesian plane, 0, -4. Okay, the next question, it says, a line has an equation of y plus 7x equals to 8. Now, very important, it must always be in this format. So we want to reshuffle it so that we only have y's equal to on the one side and all the other stuff on the other side. So once you throw that plus 7 over, it's going to become a -7x plus 8. Just want to quickly show you another one. What if I had 2y plus 4x minus 8 even is equal to 0? So then you want to get y alone, -4x plus 8, and then you're going to divide with 2 all throughout, okay, so that you get y alone. And this is your equation that you're going to work with. All right, so just be mindful of those. If it's not in the cookie cutter mold, y is equal to. Let's get another nice color. Write down the gradient of the line. So now you can see it's -7, or you can write, if you want to write nicely, the gradient is -7. Write down the y-intercept. It's this +8. So you can either say y is 8, or you can write it as a coordinate like that. Now, in your graphs, you get special lines, very special lines. There's 2 of them. One that will run parallel to the x-axis, or you can get one that will run parallel to the x-axis, or it runs vertically up and it's parallel to the y-axis. So these 2 special lines are very easy to name. This graph over here cuts through the y-axis. Let's say it cuts through the y-axis at 5 there. So because it cuts through the y-axis, the equation would be y is equal to 5. The vertical graph over here, if it touches, let's say, the x-axis at -4, then this line's equation would be x is -4. Okay, so wherever they cut through on which axes, that is the axis you name, and it's equal to that number. Okay, I hope it makes sense. So just another way that we can ask it is, write an equation that runs parallel to the y-axis. So it will be like the red graph over here. Or I can say to you, write down an equation of a graph that runs parallel to the x-axis, which would be this graph over there. Or I can ask you, write down or draw a graph that runs perpendicular to the x-axis. So can you see it will be this graph over here, because it runs perpendicularly to the x-axis. Or I can say to write down a graph that that runs perpendicular to the y-axis, which will be this y is equal to 5. So just be mindful of those. We can ask it. Okay, so a horizontal line, write down an equation, any equation of a straight line, of a line that runs horizontally and it passes through the y-axis at 3. So very easy, y is equal to 3. So it's got no gradient, can you see? It just goes straight like that. A vertical line passing through the x-axis at -2, very easy, x is -2. And now they ask you to write down an equation of a line with a gradient of 2/3. So that is the way you'll write it. The gradient is in front of the x, so 2/3, but it cuts through the y-axis at 0, so there's no backside. So you can either choose, well, you can, because it's nothing, there will be nothing at the back. Okay, so it will always pass then through the origin like that. Okay, because the y-axis, there's nothing, so it goes through 0, which is the origin. Okay, let me just erase all the extras. Let's look at the next type of question. Okay, question 2. Now, they say to you, a straight line is drawn on each grid below. Work out the equation for each straight line. Okay, so how do we get an equation when a graph has been drawn for us? I always say, start with the cookie cutter mold. Y is equal to mx plus c. Now you go look, can I perhaps work with the y-intercept there? Has it been given? Yes, what is it? It's a +3. So I can go and fill that in. Y is equal to mx plus 3. And then the only other thing I need to complete my equation is the gradient. So the gradient is, a way to work it out is if you, from left to right, can you see that I am going to sink over swim? So it always forms a triangle like that. So how many times, so if it is a negative gradient, it will be equal to how many times did I sink over how many times did I have to swim. So I had to sink with 1, 2, 3 units, and I ran or I swam with 1, 2, 3 units. And what is 3 over 3? It's 1. So the gradient, it's not 1, because we can see it's going down, it has to have a -1. So your equation would be y is equal to -1x. You don't have to write that 1 plus 3. So if you just want to clean it up, and there's your equation. Okay, so that is if we have the y-intercept there.
Here's what I found.
Oops, sorry, there's my watch talking to me. Now, what about this one? They don't give me well, actually, we have the y-intercept there. It goes through 0, 0. Okay, so now, first of all, is it a positive gradient or a negative gradient? It's a positive, it's going up. So a positive gradient, you're always going to see how much did I rise over run. So always from left to right. So from here, I'm going to rise with 1, 2, 3. And I ran, because you can see the x value there is 1, I ran with 1. So it's 1, 2, 3 over 1, which simplified gives me 3. So y is equal to 3x, And do I have any backside? No, because it goes through the origin, which is plus 0. But again, we're not going to write that, so we're just going to have y is equal to 3x. Okay, now with this one, we don't have any, let's pretend we didn't know what that scale was. We don't have any y-intercept, and we don't have the rise over run. We sort of can do, but we want to rather use our formula. So for the gradient, if you can't really see what's going on, there's a formula where you say change of y over change of x. So you must just please remember it's the change of y over the change of x. Okay, if I'm going to highlight, let's highlight the y values. Okay, so can you see the two y values is 2 and 0? So the change of y means the difference between the two y values, the y coordinates, over the difference of the two x coordinates. Okay, so difference meaning minus. I'm going to make this my starting coordinate. So from the change of x, I must also start at this coordinate. So the change of y is 2 minus, so 2 minus 0 over 2 minus what? Negative 2. So be careful for that double negative. So I'm going to show you again. 2 minus 0 over 2 minus negative 2, which will give you 2 minus 0 is 2, 2 plus 2 is 4, so the gradient is a half. So now we've got y is equal to a half x plus c. We don't know the backside. How can we get the backside? How can we get the y-intercept? We are just going to replace any coordinate. I like to take the one with no negatives, the 2 and the 2. I'm going to replace that because in fact this is a x value and that is a y value. And if I replace the y and if I replace the x, can you see the only one left as an unknown would be c. So if y is 2 and x is 2, what would c be? So 2 is equal to a half of 2 is 1. And then if you take that over, you subtract 1 on each side, you get c is 1. So thus, put it all together. Remember they asked you to show the equation of this line. So y is equal to a half x plus 1. And some for your teacher, highlight it, say there's my equation, I found it. Okay. Question 3. On the grid below, sketch the following two graphs by using the dual intercept method. Show all your calculations and plot all the coordinates on your graph. Okay, so I've got two graphs. The one is called f of x and the other one is called g of x. So let's first work out f of x, the two coordinates. So remember, we only need two coordinates to plot, to draw a straight line. Two coordinates, and that will make up a straight line. Okay. So for f of x, so can you see the one coordinate we already have? It's that y-intercept. So we've got the y-intercept, and then for the x-intercept, we're going to make y 0. So in that, you've got 0 is equal to a half x plus 1. You throw that positive 1 over and it becomes a negative 1 is equal to a half x. And then what is happening to x? It's being multiplied with a half. So I'm going to divide with a half on each side to get rid of that. And x is then equal to negative 1 divided by a half gives you negative 2. So the other coordinate here is negative 2, 0. So then I'm going to, scratch over it, highlight it. No, I want yellow. There's my 2 coordinates, and then I'm going to plot them. Let's get a darker yellow at 0, 1, and at -2, 0 over there. There we go. Sorry, I did the best I can with my ruler, but it still doesn't look perfectly straight. But please, you have to check. Did I do a straight line with my ruler? Do I have 2 arrows at the end? Did I extend my graph? And then you can also go ahead and label your 2, or you have to label your 2 intercepts. And then you have to tell me this was graph f of x. Okay, so now let's quickly have a look at g of x. I'm going to do that in orange. Okay, so g of x is y is equal to -2x minus 4. I already have my y-intercept. If x is 0, y is -4. And then we're going to say for the x-intercept, thus y is 0. And then you're going to have it like that, -2x minus 4. When you bring the -4 over, you add 4 on each side, divide by -2, and you get x is -2. Like that. Then we're going to highlight our 2 coordinates over there. And then I just want to draw, so 0, -4, and -2 over there. All right, and there's your graph. I'm going to label, this is g of x. And the way you can just double check yourself, is it a negative gradient? Yes, it is. And does it cut through -4? Yes, it does. Okay, so there's your 2 graph. Now, I just want to quickly let us analyze this. Can you see that there is a point of intersection, which is over there? What is the point of intersection? It's where the 2 graphs cut each other. Okay, where the 2 graphs intersect. So now I want to show you how you can calculate the point of intersection of the 2 graphs. So if I had to write down where f of x is equal to g of x, because you won't always be able to read it off like this as nicely. So can you see that coordinate is -2, 0. So I know it's -2, 0. But I want to show you how you get to it if you had to calculate it. So the one graph is y is equal to 1/2 x plus 1. And the other graph is y is equal to -2x minus 4. Okay, so where the 2 graphs equal each other. So what I'm going to do is I'm going to equal the 2 parts that is given as equal. Y is equal to 1/2 x plus 1 and y is equal to -2x minus 4. So I'm going to equal those parts to each other. So 1/2 x plus 1 is equal to -2x minus 4. So then I'm going to bring all my x's to the one side. 1/2 x plus 2x is 2.5x is equal to -4 minus another 1, which is -5. Divide with 2.5, divide with 2.5. And can you see that x gives you -2? Sorry. Okay, so now we've got the one part of the coordinate. How do we get the other part there, which is 0? So you're going to take this and you're going to replace it into any one of the 2 equations that we had. So by doing it, I'm going to take the one without the half, is -2x minus 4, and we calculated the x part of it is -2. So we've got y is equal to -2 times -2 minus 4. And that would give you a +4 minus 4, which gives you a 0. So can you see it gives you exactly this coordinate as read from the Cartesian plane, -2, 0. And this is the point of intersection. Okay, so that's a way of explaining how you get to it. But if you can read it off, then you can see it's over there. But if you can't read it off or it's not clear, then you equal the two graphs to each other, get the x part, replace it into either one of the equations that you're working with to get the y part, and then you put the two together as your coordinate of the point of intersection. Okay, then let's quickly look at question 4. Right, let's look at these type questions. Question 4, a line has a gradient of -4 and passes through a point. So again, we're going to start with our cookie cutter. Y is equal to mx plus c. And they tell you the gradient is -4.5. So I'm going to replace the m with -4.5x plus c. And like we did with the previous one, we're going to replace this point where the x is, where the y is 5 and the x is 10. And then with that, we will be able to find the only missing variable there, which is c. Okay, so 5, -4/5 times 10 plus c. If you simplify that, 40 divided by 5 is 8, -8 plus c. So c is equal to, if you add 8 on both sides, you will get c is 13. All right, so now remember, you have to find the equation. So you have to go write up your equation that you got is -4/5x plus 13. All right, let us highlight that. When I watch these videos, the whole time I can hear, okay, all right, okay, can you see? It must irritate all of you, so sorry. Okay, there we go again, okay. All right. The point A, -4,5, and the point B, 1, -10, lie on a straight line. Find the equation of the line. So we've got y is equal to mx plus c. We don't have a y-intercept because we don't have it where it's 0, 5 perhaps, or 0 something. So we can't use the y-intercept. We have to start with the gradient. And the way to find the gradient, do you remember, is the change of y over the change of x. So if you take the two y values, I always put them in little hearties just to highlight them for me so that I don't get confused. The change of y, which is -10 minus 5. So you take, if you start here, then always this would be your first coordinate and you are deducting the second coordinate. So -10 minus 5 over the x values, change of x, 1 minus what? Minus 4. So please be careful of the double negative. It's 1 subtract -4. So 1 subtract -4. So that would give you -15 over 1 plus 4 is 5. So it gives you -3 as the gradient. Whoop-de-doo. So go and fill it in. -3x plus c. And now to get c's value, we're going to replace a coordinate. Which one? Let's try this one. -4, 5. Okay, we're going to replace a coordinate. It doesn't matter. You can go and replace both and you'll see that you get the same answer the whole time. So y is 5 and x is -4. So 5 is equal to a negative times a negative is a positive 12. So c is equal to 5 minus 12, which gives you -7. And there you've got your equation. Y is equal to, what was the gradient? -3x minus 7. All right, and you can also go and double check it. If you replace, let's say, this point, just to make sure, the y is -10 and the x is 1. Does left-hand side equal to the right-hand side? Yes, it does. Okay, so if you always want to check yourself, or if you've got a little bit of time left in the exams, check yourself, make sure that you've got it right. All right. Again, just another one. There's another 2 points that lies on a straight line. Find the equation. So first of all, cookie cutter mold. Y is equal to mx plus c. Start first with finding the gradient. There's no way that we can find the y-intercept unless it's given to you 0, 2, or 0 something. So the gradient is equal to change of y over change of x. So I'm going to highlight my y values just so it stands out. So it's minus 2 minus another 2. So I'm going to start here and then I subtract the first coordinate. So minus 2 minus 2. And then again, I'm going to start here with the second coordinate, 10 minus 2. Okay, you could have done it the other way around, just to show you. You could have said 2 minus 2 and 2 subtract 10. Do you see? As long as you start, if you start with this one and then this one second. So for the x as well, start with this one and do the difference of the second one. Just to show you that it gives you the same answer. So negative 4 over 10 minus 2 is 8. So the gradient is negative a half. And over here, 2 plus 2 is 4. 2 minus 8 is negative 8. So the gradient is negative a half. Okay, so see, gives you the same. Now I've got my gradient. Negative a half x plus c. How do I find that c? I'm going to replace a coordinate, and I'm going to choose that one. Why? Because it's got no negatives. So 2 is equal to negative a half times 2 plus c. A half of 2 is 1, so it's negative 1 plus c. So c is equal to, if you throw that negative 1 over, it becomes a 3. Okay, so your equation, build it back together. Negative a half x plus 3. And there's your equation. Not so hard. Then just a few more questions, then we're almost done. Write down the equation of a line that will run parallel. Parallel means the same gradient, but I need to change the backside to anything. What's your favorite number? 10, 7, minus 5, minus 10, anything at the back as long as you've changed it. Number B, write down an equation of a line that will run perpendicular. So now, first of all, we need to reshuffle it into the cookie cutter mold. So 2y is equal to negative 8x plus 4. Hope you agree. So the plus 8 went over and became a minus 8. So thus, y is equal to, if you divide by 2 all throughout, negative 4x plus 2. So if they run perpendicular, what do you do with the gradient? So if they run parallel, the gradient stays the same. But if they run perpendicular, which means they meet at a 90-degree angle, it means that the gradient of the one times the gradient of the other must give you negative 1. All right, but there's an easy way of doing it. You take the gradient, which is negative 4, you force it into a fraction, and then you flip it around and you change the sign. So that negative becomes a positive. So what would the line be? Y is equal to a quarter x plus 2. Sorry, my dogs are going crazy downstairs. So a quarter x plus 2. You can keep it now the same, or you can change it into your own favorite number that you've got. Anything. But the most important here is that we want to see that you've changed that gradient. Flip it around, force it into a fraction, flip it around, change the sign. Okay, I hope it helps. This type of question, the equation of 4 lines are given below. Which lines go through the point 2, 9? So if I go and replace the x's value with a 2 and the y's value with a 9, which of these lines gives me the left-hand side equal to the right-hand side? So that's basically what they're saying. So if we take line A, and the y value we put in as 9, and the x's value we put in as 2. Do I get the left-hand side equal to the right-hand side? Yes. So that means that line A does go through the point 2, 9. Let's try line B. You can reshuffle it if you want. In this case, it wouldn't really matter. Okay, so y is 9 and x is 2. So 9 is equal to negative 4 plus 8, which gives you a positive 6. Negative 4 plus 8 is 4, sorry. But in any case, we can see that the left hand does not equal to the right hand. So this line does not go through the coordinate 2, 9. All right, so if you had to look for line C, it's 4, okay. Line C, you would say y is equal to, let me not change it, y is equal to 9 minus 2x. So y should be 9 and x is 2. And 9 minus 5 is 4. So no, it doesn't go through. Last one, line D, y minus 3x is equal to 3. If I replace the y with the 9 and the x with the 2, minus 3 times 2 is equal to 3. And the last one does go through because 9 minus 6 does give you 3. So the two graphs that does go through is line D and line A. All right, just all types of equations that you can get. All right, question 6. Find the point of intersection of the following two graphs. Point of intersection is where the two graphs, if you had to draw it like this, will cut each other. Okay, sometimes you can't see it on the Cartesian plane, so you have to work it out. What do? We're going to equal the two parts that is equal to y to each other. So x plus 3 is equal to negative 2x plus 6. Because if they're both equal to y, they are both equal to each other. Hope it makes sense. And then you're just going to solve for x. So 3x is equal to 6 minus 3 is 3. So x is 1. So now I've got my first part of the coordinate, the point of intersection. So the point is the coordinate that they are looking for. How do we get the y part? You take this x is 1 and you go and replace it into which one? That one, or you can choose the other one. It doesn't matter. I'm going to choose this one because it's nice and easy. So y is equal to x plus 3. We found that x is 1. So y is 4. And there is your point of intersection. All right, very easy peasy. Same with here. If you had to find the point of intersection, is equal to 2x plus 6. And 6 plus 4 is 10. So x is negative 2. Take your answer. Go and replace it into the one that looks the easiest. So y is equal to negative 4 plus 6. So y is equal to 2. What is the point of intersection? Negative 2 and 2. Sorry, I'm just going a little bit faster. There's your point of intersection. Last one. So, oopsie. We equal it to each other. Then we solve for x. So if we divide by 4, just be careful with this one. It gives you a negative 1/2. So you take that, although it's not a nice number, negative times negative 1/2 plus 2, 1/2 plus 2, which gives you 2.5. Okay, you can write it as a decimal or a fraction, it doesn't matter. So the point of intersection is negative 1/2 and 2.5. That's how quick and easy it is. I hope I haven't gone too fast because I'm feeling like I'm irritating you. 3x plus 3 is 4x. 2 minus 4 is negative 2. Divide with a 4 on each side. You get x is negative a half. Go and replace it. Which one? You could have also replaced it into that one. Let's replace it in there and see if I get the same. Half times 3 is 1.5, so it's negative 1.5 plus 4, which also gives you 2.5. All right, so it doesn't matter which one you replace it in because it's equations that are equal to each other, that you equal to each other, you will get the same regardless of which one you replace it in. And now this is a very nice level 4 type question for those smarty pants out there. It says, sketched below are the graphs y is equal to x plus 2 and y is equal to 8 over x. So this one you shouldn't know yet. Maybe in grade 10 you know it already, but that is a hyperbola. So now they say to you, determine the coordinates of A, one of the points of intersection between the two graphs. And they are looking for this coordinate over there. All right, so if I had to write it down, y is equal to x plus 2. And the other one, y is equal to 8 over x. So when you see point of intersection, you must think equal these two graphs to each other. Right, so we're going to say x plus 2 is equal to 8 over x. How do I get that 8 over x away? I'm going to multiply with x all throughout. Okay, or you can find a common LCD and say I need to make them all an x. But x times x is x squared. 2 times x is 2x. And 8 over x times x gives you just 8. And that is a quadratic equation. So what do we have to do? We have to first equal it to 0 because we're going to have two answers for x. And what does that look like? A lovely trinomial. Hopefully you can still remember how to factorize a trinomial. If you can't, I've got videos on that. Okay, the signs are different. The first one is a plus, minus. What times 8? 4 times 2 gives you 8. And 4 minus 2 gives you a positive 2. So x is either negative 4 or x is 2. Now, which one do we choose? We have to go look at, sorry, I want a nice different color. We need to go look at the graph. What do you think this point represents? If you had to take it down, do you think x would be either 2 or with this point represent 2 or negative 4? I hope you can see that this side would be a positive because x is on the positive side there. So we're going to use this one. X is 2 because they are looking for point A. Then I'm going to replace it into which one? Any one. Can I choose this one? Yes, you can. Can I choose that one? Yes, you can. Just to get the other y part of the coordinate. So if x is 2, can you see 8 divided by 2? Y is then 4. If I had to replace it in here, 2 plus 2 gives you also 4. So the point of intersection is where x is 2 and y is 4. For a lovely, how many marks? 6 marks. I hope you, after looking at it, you say, okay, so point of intersection, you equal them to each other, and then you find the x part, replace it back into the equation to find the corresponding y part of the coordinate. And that is it. Grade 8, grade 9, grade 10, whoever is watching. I hope you understood. I know that I ran quite fast through it, but I hope it gave you a good indication as to all the types of questions that you can get for the straight line graph. I know some schools only started in grade 10. I think that's quite late. Although in grade 8 and 9 you did do the input and the output values of X and Y. But in our school, we start learning to draw it already in grade 8, and we start learning about the gradient. When are the gradients the same? When is it perpendicular, etc. But wherever you are, I hope this video helped, and I hope you have a great day, and thank you so much for watching. Bye.